In the time it takes me to speak these opening words is the time that it took Space Shuttle Challenger to launch on the 28th of January in 1986, then to explode seconds later, killing all the astronauts and including the first, what was going to be the first non-astronaut, civilian teacher, Krista McCullough. The cause of the disaster was established quite quickly. President Reagan, who was the president at the time, set up a commission to investigate what happened and why did this explode like this. They discovered the cause very quickly. But for us to understand what happened, we need to take a look at the shuttle itself. The shuttle is made up of different components. So we have this area here, which is called the orbiter. This is what looks like the aeroplane part of the shuttle. This is where the astronauts sit, and this is where they do all their experiments. And this is the part that's supposed to come down to land afterwards. It's fueled by this big orange fuel tank, which has liquid fuel in it. It's aided by these two external rockets. These are solid rocket boosters. The aim is to get the whole of the shuttle off the ground and up into space. It was these areas where the fault was found. You may look at it and think, well, that's just a single rocket. But, in fact, these solid rocket boosters are made up of separate components. They are brought to the launch pad in Cape Canaveral, and then they are slotted together. It's a bit like if you looked at the garden hose. These fit together snugly like so. What they have inside of these big rockets are huge rubber rings called O-rings. The aim was that once the sections are put together like so, it forms a seal so that when the hot gases come through the rocket, they don't leak. However, during the course of the investigation, Richard Feynman, who was a Nobel Prize winner for physics, he did an experiment where he took a piece of the O-ring and he demonstrated that if you should immerse this into cold water of a temperature of 32 degrees and then remove it after a few minutes, the elasticity of the O-ring does not go back to its original format. And this is what happened. On the night of the launch and the morning of the launch, it was one of the coldest. It was probably the coldest launch. 36 degrees. They had battles going on between the manufacturers of the rockets, Morton and Thoryckel, and NASA to try and understand whether they should or should not launch. You can see the ice that was all over the shuttle, and this was in the morning of the launch. The launch was actually delayed by an hour so that they could get rid of the ice, because the ice was considered to be a danger to the whole of the shuttle. Because once the shuttle launched, shards of ice would fall off and could penetrate into any part of the shuttle itself. When they looked at the photographs of the launch afterwards, they noticed there were puffs of smoke. And these puffs of smoke came from the joints of the solid rocket boosters, indicating to them that the O-rings, these rubber bands, had failed. Failed because of the cold weather. They hadn't closed properly. That puff of smoke indicated that was escaping hot gas. And in the next sequence, you can see that what started off was a small little flame, grew and grew. This was impinging on the membrane of the liquid fuel tank. And then after 73 seconds, a hole was penetrated inside here, combusted, killing everyone on board. So why was it allowed to launch? Morton Thoryckel were not stupid. They knew the ins and outs of the shuttle. They had analysed the launches in the past, and they knew that there was a weakness with these O-rings. And they were up to 2 o'clock in the morning arguing with NASA that the launch should not go ahead. Now, someone argued that perhaps it was the presentation of the data by the engineers that caused the problems and caused the launch to actually go ahead. This is an example of the type of presentation that the engineers gave. They had all the information, but if you look at it, it looks very confusing. What they were trying to illustrate there, when at first sight you look at that diagram, you think crayons, you don't think rockets. But this is an indication of the rockets themselves, and they indicated where there were faults on it. Now, there was a data statistician who looked at visual data called Edward Tufte. He argued that had they taken that same information and put it onto a scattergram, the launch would never have happened. Because he argued that when you look at the scattergram, over on the left-hand side is the damage caused by coldness on these O-rings, and that at warmer temperatures of 65 and above, there's very little damage to these O-rings. But the morning of this launch, the temperature was forecast for 26 degrees, indicating that the damage was going to be so off the scale that there was no way that it was going to launch. Now, you may be wondering at this point, what's that got to do with us as Toastmasters? Why should we care? Why should we be interested? Why I think we should be interested is that we do presentations. One thing what we should not underestimate is the power and the pressure that some people can put you under when you're doing a presentation. And this is what struck me about all of this, the whole of this Challenger, was that I am going to argue that it was financial and political pressure that caused the disaster. You see, NASA were in the doldrums. They had hit the heights with the Apollo launches, and they had the Challenger shuttle. They had the shuttle running, but they were running out of money, and they needed to persuade the US government to keep the program running. So what did they do? They found, we've got the safest method of transport in the world. We're going to prove it by putting a teacher into the shuttle and launch her with the other astronauts. And that's what they did. Morton Thoykel, who were the manufacturers of the rocket, well, they had billions of dollars of investment with NASA, and they were not about to turn around and bite the hand that feeds them. So they were in a bad predicament about allowing the shuttle to launch. And then there was the political aspect of it. President Reagan was also looking for a way of showing his popularity and how great America was in the world. So he had worked with NASA to engineer it such that once the shuttle was in space, he would have a telephone link directly to the shuttle, and he would speak directly to Krista McCullough, who was the school teacher on board. And I believe it's because of all of these reasons was the reason that they made the fatal mistake to allow the shuttle to launch. But I'll leave it to Richard Feynman, who I believe says it right, where he says, for successful technology, reality must take precedence over public relations, for nature cannot be fooled. Got time for some questions?
Yes, yeah, you got a couple of minutes.
Okay, good. Would anyone like to ask any questions about this? Rory?
So clearly they knew there were issues with the O-rings long before the actual disaster that day.
They did, yes.
Why was action not taken to replace the O-rings, or more preventative action?
There had been. They had been looking at proactive ways of making these O-rings safer. But up to this point, they could not demonstrate that by allowing the shuttle to launch that it was going to be fatal. Because up to that point, none of the launches had been below 55 degrees Fahrenheit. This was the coldest at 35 degrees. So they were in unknown territory.
Mm-hmm. So was any of that information about the O-rings released or made available to any of the astronauts, the teacher?
all of the information was in the public domain because there was constant dialogue going on between NASA and Morton Thoyko. So all that information was shared. If you imagine, if you look at the shuttle, and what struck me about it, it's great in hindsight to say, oh, well, they should have realised that. But the complexity of all of these components to make this up, to focus on one area and to say, aha, well, it's obvious that was the problem. There were many other areas that we're looking at. And the night before, they were deluged with the amount of information that the Morton Thoyko were presenting. It was one of those areas that it just so happened that they got it wrong.
Was anyone found guilty, and as a consequence, is the music?
There was there was a lot of finger pointing at Morton Thoyko and at NASA. Heads did roll, but no one was taken to court, as far as I'm aware. I have one more question. Sylvia.
What did they learn from it?
Well, that's very interesting. What did they learn from it? They didn't learn a lot because it took until the following shuttle, which was Discovery. Once that was destroyed, when they started to take the lesson seriously. That's what happened. Okay.